Okay, now we have 8-bit adder and we can make arithmetic unit for our processor. Because adder can be used to perform multiple arithmetic operations, and let's check out how they look like. So I will first make this assumption that with adder we can perform the following functions. We can add two numbers, we can add two numbers and carry. We can also use an 8-bit adder to increment one number. Increment means in programming language plus plus, incrementing a number by one. You know, x plus plus means just add one to x. And since loops and counters are very popular in programming, then increment instruction is built into almost all microcontrollers and processors, CPUs, because it's so popular. It only needs one register. You give register A and it returns A plus 1. Next is decrement, dets, which is the opposite of increment. It means minus 1. So you take a number and it calculates this number minus 1. Next is negate, calculate the negative number. I give you 5, you return me minus 5. So this calculates the negative number of a given positive number. Next is subtract, sub. Next is subtract with carry. And since these functions cover all of arithmetic functions that we might need, we will add the last one, move, which is basically just copying the number to a second register. For example, you can realize it by adding 0 to register B and saving the result into register A. So these 8 functions can be all implemented with our 8-bit adder in a special way, which we will do right now. So first, let's create a table in which we put an overview of these functions. So let's say we have the following inputs. We have inputs A, B, and carry in. And let's say how we can realize these first 8 functions. So we have input A, B, and carry. And what we want to do is we want to perform functions add, add with carry, increment, decrement, negate, subtract, subtract with carry, SBC, and move. So for our arithmetic unit, we have inputs A, B, and carry. I'll write it carry in. And how can we perform addition, for example? To add two numbers without carry, we add A plus B, but instead of carry, we will force this case to, instead of carry, always add 0. So instead of carry, we will use 0. To add with carry, we add A plus B, and instead of 0, we use the actual carry value, carry in. Next, to increment a number, we select number A, but instead of B, we will select number 1, and carry in will be 0. In this case, our 8-bit adder takes A plus 1 plus 0. So we will put some multiplexer which switches between B and 1 depending on which function we want to perform. Next, decrement. We take A, and instead of B, we will add minus 1, which is equal to 0x f f. We can open this calculator, we type 1, calculate the minus 1, and minus 1 is ff. So A minus 1 is the same as A plus 0x ff. So instead of B, we will select ff, and carry in will be 0. Next is negate. How do we calculate the negative number? So, as written previously, minus A is all bits of A inverted plus 1. So, to perform this is the formula to calculate the negative number from positive number. Invert all bits and add 1. So here, instead of A, we will select not A. We will just add one not element in front of A. Instead of B, we will use 1, the same as for increment, and for carry in, we will just select 0. We don't use it. Next, how do we subtract? So subtracting means A minus B is equal to A plus minus B equals to A plus all bits of B inverted plus 1 equals to A plus B with inversion plus 1. So for A, we take A. For B, instead of B, we let B go through one NOT gate, B. And for carry, we will use, instead of 0 or carry in, we will just use 1. We will force carry equal to 1. And this way we can do this A, not B, and 1. And next is, how do we add carry with minus 1 and minus carry? We do it the following way. It is A minus B minus carry, right? And it is A minus B is A plus B with inversion minus carry equals to, let's check it out in this example, the opposite of carry. Okay, so A plus B minus carry, and it is A plus B with inversion plus 1 minus carry. And if you understand anything about Boole algebra, how much is 1 minus carry? So if carry is 1, 1 minus 1 is 0. So it's the opposite of carry. And if carry is 0, 1 minus 0 is 1. It's again the opposite of the original carry value. So 1 minus something in Boole algebra means the inversion or the opposite of that something. So A minus B minus carry is A plus B with inversion plus inverted carry bit, because 1 minus C is inversion of C. That's how it is. So for A input, we select A. For B input, we select B with inversion. For carry in, we select C in with inversion, so inverted carry in. And finally, to copy from B to A, we will select this input as, so how to copy value from B to A. Instead of A, we will select 0, and for B, we select B. So 0 plus B is equal to B, and result will be written back to A through general purpose registers. So copying is simply, instead of A, we take 0, for B, we take B, and for carry in, we take 0. And as a result, we can, the result is just equal to B, and if we store it back in A, it means that we have moved B into the resulting register A. So this is how we can make all of these functions using only a simple 8-bit register and with some multiplexers. So let's go ahead and try to do it in Logisim. So this is our schematic with 8-bit adder. Now let's make a new sub-circuit, which we will call Arithmetic Unit. Arithmetic Unit. And I will keep this open. Like this. So our arithmetic unit has the centerpiece 8-bit adder right here. It accepts A, B, and carry in. So let's put these inputs A, which is 8 bits, B, which is also 8 bits, and let's make them face south so that the output is down, like this. This is A, this is B, and we also need to add carry in. And it will be facing down, so south. And now the first addition would be A, B, and 0. So I would just take A to first input, B to the second input of 8-bit adder, and instead of carry in, I would select 0. But since we have other possibilities, I will just immediately put a multiplexer before each of these inputs, because at different functions we have different inputs. So I go to plexers, multiplexer, and I have 8 combinations, which means that our multiplexer has 3 select bits. It will have 8 data bits, and it will be facing, I guess, south, like this. And it does not need enable signal. So I will have one for A, one for B, and also one for C. So the output of A goes here, the output of B goes here, and the output of carry goes there. Oh, and this one is actually one data bit, it's just one carry bit. And I will have another input, which will be operation selection signal. So I will call it cell operation select And since we have 8 different combinations, it means that data bits are 3. And this selection signal will be connected to all of these multiplexers at the same time. So I select, for example, add will be 0, 0, 0. It will automatically select on the first mux A, on the second B, and on the third 0. Like this. And so, first case, to perform addition, the first input is just A. The second input is simply B. And the third input is not carry in, but is 0. And in this logisim thing, you can place an object called constant. Under, I guess, wiring, you can select constant, place it, select data bits is 1 and value is 0, and it's facing south. So instead of carry in, for the first case, we select 0. And in this case, if we select operation 0, 0, 0, which is add, it forwards A, B, and 0. And the result will be just A plus B, that's all. Like this. Okay, so to perform next operation, addition with carry, the first input is again A. For the second option, oh, maybe we can actually just test online the result. So I put also output, which is Q. It's facing north, and its size is 8 bits. And it's connected to this output. So there's a little bit of error. Let's see. There is some error right there. Let's see what the problem is. Carry in is undefined, so maybe there is some problem with connection. Okay, let's fix this. Okay, everything fixed. I just need to close and open this logisim. There was some error. Okay, let's check out. So to perform addition, A plus B, for example, we select operation 0, 0, 0. It means A, B, and 0 are forwarded, so it's just A plus B. Let's say A is 15, B is 28, 15 plus 28, 43. Let's check out on the calculator. 15 plus 28 is 43. It's right here. Okay, so this part works. Let's go ahead and perform this addition with carry. To add A, B, and carry, we need to select first input is A, next input is B, and the third input is carry in. And now when I select operation number 001, it adds these two numbers and it also adds carry. So 15 plus 28 plus carry equals 0 is 43, but if we change carry in from 0 to 1, the result is 44, so it added +1. This is used to add big numbers, you add lower parts and then higher parts with carry bit also set. So this thing does add and addition with carry. Next part is increment. So for increment function, we need to select first input is A. Second input, instead of B, we will use a constant number 1. So again, under wiring, constant, what means 1? It means 0, 0, 0, 0, 0, 0, 0, 1. So 8 bits, 0x01, facing south, and I put it here. So instead of B, it will use constant number 1 as input. And instead of carry in, it will use 0. So if I select operation number 2, it does the following. It takes A in this third input. Instead of B, it takes 0, 1. And instead of carry in, it takes constant 0. It's forwarded all three values, 15, 1, and 0. And the result is 16. 15 plus 1 is 16. So if we change the value, for example, 28 plus 1 plus 0 is 29. So this thing increments A and puts out 8 plus 1. Next is decrement. It is A minus 1. Minus 1 is the same as 0xff, so I can take this constant, I can copy it, I can change its value from 1 to ff, and I attach it to the next input. So the first input for our 8-bit adder in this case is A. Next input is FF, and the last input is 0. So instead of carry in, we use 0. And in this case, let's see what happens. The value is 28. The second input is, sorry, I changed the selection of operation to 0, 1, 1, which is 3. So first input is 28. Second is either 255 if unsigned integer, or minus 1 as in our case signed integer, plus 0. We can change the carry in, it's ignored. So 28 plus minus 1 is 27. So it works. Okay. Next is negate. So we need to calculate the negative number of A in 2's complement form. So instead of A, we will use A with all bits inverted. So I take the NOT gate, I select its data bit number to 8. Size is narrow, facing to south. And so in this input, I select A through NOT gate. So here output will be all bits inverted. And for B, as I can see here, instead of B, I take 1. I already have constant 1 here, so I just feed it to the next input. And for carry is 0, so I forward carry here. Now, when I take the selection tool and I select operation number 4, it takes the fourth input here. So A with all bits inverted. B, it takes 1. And for carry in, it takes 0. So it's A with all bits inverted plus 1 is here. So input A is 28. And the output of 8-bit adder is minus 28. So this thing calculates the negative numbers in 2's complement form. Next is subtraction. So for subtraction, we take A as our first input, B with all bits inverted as the second input. So I can just take this inverter NOT gate and copy it and put B through it. And instead of carry in, I use a constant 1. So I take this constant 0, I copy paste it, and instead of 0, I want it to be equal to 1, and I connect it here. So to calculate subtraction, we take A then B with all bits inverted, and 1. So A, so I changed this operation to operation number 5, subtraction. So it's A, which is 28, plus B with all bits inverted, plus 1, and the result is, oh, the input is 28, the other input is 28, the result is 0. Okay, let's say we want to subtract, for example, 62 minus 28, and the result is 34. 62 minus 28 is 34. So this thing is calculating it correctly. And we're using the same 8-bit adder for all of these functions. The next part is subtract with carry. So it's A. First input is A. Second input is B with all bits inverted. And instead of carry, we use the inverted value of carry. So I take NOT gate facing south. And for this, I select carry inverted. So when I select operation number 6, it takes A, B with all bits inverted, and carry bit inverted. So in this case, 62 minus 28 minus 1, let's say I set carry equal to 1. So 62 minus 28 minus 1 should be 33. And it's the output, 33. Subtraction with carry is A minus B minus carry in. And finally, mov operation. So instead of A, I use constant, 8-bit constant 0, facing south. Instead of anything else, I use just B directly. And for carry in, I use, again, 0. And in this case, it's 0 plus B. The output will just be always equal to B if I select operation number 7. So, it outputs B. And this way, we will be able to copy the value of the second register through general purpose register into first input later. So this is our arithmetic unit. And we will add 2 more outputs, the round bubbles facing east. The first one is carry out result of this addition. So I'll name it C out and connect it here. And also the signed overflow bit facing east, V, from this addition. In most cases, they are not really used, but in some cases, when we want to add big numbers, we want to use these bits. So they are defined as outputs. And this is our arithmetic unit. It uses single 8-bit adder to perform addition, subtraction, increment, decrement, addition with carry, subtraction with carry, and copying 2 bits, and also calculating the negative value of a number. It's like multiplying with -1. Okay, and now we want to finally just go to this sub-circuit appearance. And how do we want to organize these inputs? So I will make this box a bit larger, for example, this big. And so A input is here, B input will be here, carry in will come from the right side. I don't need this thing. This is our output Q. It will be at the bottom part. This is our V flag. This is our carry flag. It will be on the left side. And this input is operation selection input. So this is operation selection input. And this carry, okay, let's just leave it there. So the text is arithmetic unit. So this thing does math functions. And I can just save it, and that's all. This operation selector just selects which function to perform. So that's all for this lab.